All right, moving on to the new material from section 9.1, the 6 trigonometric functions. So you thought there was 3 trigonometric functions. You know about sine, cosine, and tangent. But it turns out they have friends. So in addition to sine, cosine, and tangent, we have their friends. Cosecant is abbreviated CSC. So the cosecant of an angle theta is equal to the reciprocal of sine, 1 over sine theta, or the hypotenuse over the opposite side. The secant of an angle is abbreviated SEC. Secant theta is the reciprocal of cosine, which means it's equal to the hypotenuse over the adjacent side. And the cotangent of an angle is abbreviated COT. Cotangent theta is the reciprocal of tangent, so it's equal to the adjacent side over the opposite side. So for example 4, we're going to evaluate these 6 trigonometric functions of the angle theta. We have a right triangle. This angle up here is theta. We know this side here is 7, and this side here is 24. So labeling the sides with opposite, adjacent, and hypotenuse from this angle theta, this side would be the opposite side. The side across from our right angle is the hypotenuse, and the side next to our angle is the adjacent side. The first thing we're going to do is find our missing side using the Pythagorean theorem. Our Pythagorean theorem says a squared plus b squared is equal to c squared. We know it doesn't really matter which one we call a and b in this case, but c is important that it's the hypotenuse. So I'll say a is the 7 squared plus b is 24 squared equals c squared. 7 squared gives us 49. 24 squared gives us 576 is equal to c squared. 49 plus 576 is 625 equals c squared. And if you take the square root of each side, c equals the square root of 625, which happens to be 25. And now that we know all 3 sides, we can write the 6 trig ratios. We do want to simplify those fractions if possible. So for example, not that it's matches these numbers here, but if you had gotten the fraction 2 over 4, you should simplify that to say that's 1/2. Right. So we know the sine of our angle is equal to the opposite side over the hypotenuse. So from our angle, our opposite side is 24 over, we figured out our hypotenuse is 25. Cosine of our angle is equal to the adjacent side over the hypotenuse. Our adjacent side is 7 over our hypotenuse 25. The tangent of our angle is equal to the opposite side over the adjacent side. Our opposite side is 24 over our adjacent side is 7. In all of those fractions, there's nothing we can do to simplify them. There's nothing that goes into both 24 and 25 or 7 and 25 or 24 and 7 other than 1, which doesn't help us to simplify. All right, and then our friends, cosecant theta is equal to hypotenuse over opposite. So our hypotenuse was 25 over 24. Secant theta equals hypotenuse over adjacent. Okay, remember that secant is the reciprocal of cosine. So if you know cosine, you can just flip it over. Get 25 over 7. Cotangent theta is adjacent over opposite, or the reciprocal of tangent. So when I flip that one over, I get 7 over 24. And now we have our 6 trig ratios. And that's all we have to do for that problem. Again, nothing that we're going to be able to do to simplify those fractions in that particular case. Our last example for today, example 5. In a right triangle, theta is an acute angle. And cosecant theta is equal to 6 over 5. We are going to evaluate the other 5 trigonometric ratios for theta. All right. The first thing we're going to do in this example is to draw and label a triangle. We know cosecant of an angle is equal to the hypotenuse over the opposite side. So our hypotenuse is 6. Our opposite side is 5. So hypotenuse across from our right angle is 6. The side opposite of our angle is going to be 5. And our other side, the adjacent side, we don't know yet. So that'll be what we want to find next, our missing side. And we can do that since we know 2 of the sides with our Pythagorean theorem. A squared plus b squared equals c squared. So A and B are our legs. We know one of the legs, so I'll say A is 5 squared. Plus we don't know the other leg squared, but we know our hypotenuse is 6, so 6 squared. Well, 5 squared is 25, plus b squared equals 6 squared is 36. If we subtract 25 from both sides, we get b squared equals 11. And if you were to take the square root, b equals the square root of 11. On these problems, make sure you use the exact value, no decimals. And now that we know all 3 of our sides, we can write out our ratios. All right, we know sine of an angle is equal to the opposite side over the hypotenuse. So from our angle, our opposite side is 5. over our hypotenuse is 6. Cosine of an angle is equal to the adjacent side over the hypotenuse. Our adjacent side we found is square root 11 over our hypotenuse is 6. Tangent is equal to the opposite side over the adjacent side. Our opposite side of our angle is 5. Our adjacent side is our square root 11. Now this presents a problem for us. Having a square root in the denominator of a fraction is not considered simplified. So to simplify, when there's a radical in the denominator, you're going to multiply, and I should be specific. This trick is only going to work with a square root. It would be a little bit different if it was like a cube root or a fourth root, okay? So to simplify with a square root in the denominator, we're going to multiply the numerator and denominator of the fraction by that radical. So we have right now that tangent theta is equal to 5 over square root 11. Well, if we multiply the numerator, the top, and the denominator, the bottom of a fraction, by square root 11. 5 times square root 11 is just 5 square root 11. Square root of 11 times the square root of 11. 11 times 11 is 121, and the square root of 121 is 11. So when you multiply two of the same square roots together, you just get the number that was underneath the square root, which is the whole reason that we did this. It's called rationalizing the denominator. Okay? If you have a calculator with a fraction button on it, like our calculators at school, if you were to type in 5 over square root 11, it would simplify that for you and tell you that 5 squared 11 over 11. But if you don't have a calculator to do that for you, this is the work that you would need to show to be able to get the correct answer. All right, we have a few more trig functions to finish up the other 5. Remember, we already knew that cosecant was 6 over 5. But we do need to write out our fractions for secant. Now, secant is equal to the hypotenuse over the adjacent side. Our hypotenuse is 6. Over our adjacent side is square root 11. Uh-oh, it happened again. We've got a square root in the denominator. We need to rationalize it. We need to fix it. So we're going to multiply by square root 11 over square root of 11. 6 times square root of 11 is 6 square root of 11. Square root of 11 times square root of 11 is 11. And our last trigonometric function, cotangent theta, is equal to our adjacent side over our opposite side. Our adjacent side was square root 11 over our opposite side is square root 5. That's already simplified. There's no radical in the denominator, so that is our answer. And that is everything that you need to know to be able to do your assignment from section 9.1. Good luck.